Tekrar merhabalar. Yavaş yavaş başlayabiliriz diye düşünüyorum. Yeterli çoğunluğu katılım anlamında sağlamış bulunmaktayız. İsmim Necdet Apaydın. Profen İletişim Teknolojilerinde Genel Müdür Yardımcısı görevini yürütmekteyim. Yaklaşık 13 senedir Profen'de bu sektöre hizmet veriyorum. Tüm katılımcılarımıza hoş geldiniz diyorum. Saygılarımı sunuyorum. Umuyorum herkes için verimli bir program olur. Biz her sene 20'den fazla bu sayıda bu tarz etkinlikler düzenliyoruz. Tabii bu sene biraz daha bu etkinlikleri arttırma ve sıklığını daha da aralıklarını azaltarak düzenleme ihtiyacı hissediyoruz ve bu motivasyonumuz gün geçtikçe artıyor sizin değerli katılımlarıyla. Takdiriniz pandemiden dolayı fiziki ortamlardaki etkinliklerin azalması, hatta hiç yapılamaması nedeniyle bu sosyal medya ve dijital platformu daha sık kullanır hale geldik. İnşallah pandemi sonrası tekrar bu tarz etkinlikleri yüz yüze hem hoş sohbet edecek şekilde gerçekleştirip hem de daha sosyal bir ortamda, interaktif bir şekilde gerçekleştiririz diye umut ediyoruz. Umarım herkesin sağlığı, sıhhati yerindedir. Biz bu etkinliklere Teknoloji Günleri adını verdik. Profen Tech Days. Ve bu etkinliklerde sizleri tedarikçilerimiz, çözüm ortaklarımız ve dünyanın birçok önde gelen teknoloji üreticileriyle buluşturuyoruz aslında. Buna gayret gösteriyoruz. Bugünkü etkinliğimizde de yine bunlardan biri olan Orolia firmasıyla sizleri buluşturuyoruz efendim. Profen İletişim Teknolojilerinin bugün 80'e aşkın bir çözüm ortağı var. Bu çözüm ortakları içerisinde birden farklı segmentte hem üretim yapan hem çözüm üreten, servis sağlayan firmalar var. Orolia'da da bunlardan biri ve en önemlilerinden biri aslında bizim için. Çünkü özellikle kamu ve savunma sanayindeki uygulamalarda çok tercih edilen, yine enterprise ve finans sektöründe oldukça geniş bir kullanım alanına sahip konumlandırma, navigasyon ve zamanlama çözümleri, ürünleri üretip pazarlayan bir firma. Bununla beraber geçenlerde yine bir etkinliğimiz olmuştu. Simülasyon uygulamalarıyla alakalı, GNSS simülasyon uygulamalarıyla alakalı. Yine orada da oldukça alanında lider, sektöre yön veren bir üretici. Bugünkü konumuzun ana başlığı aslında konumlandırma, navigasyon ve zamanlama yine. Kısa adıyla PNT diyoruz ama alt başlığımız, yani üzerine konuşacağımız konu ise GPS, GNSS sinyallerinin bozulmasıyla alakalı. Bunları nasıl tespit ederiz? Bunlardan nasıl korunuruz ve önleme ile alakalı uygulayabileceğimiz çözümler nelerdir? Bunlardan bahsedeceğiz. Ben programa başlamadan önce tabii sözü oradan bizimle beraber olan arkadaşıma devredeceğim ama hazır biraz sizleri yakalamışken çok kısa firmamızdan ve faaliyetlerimizden de biraz bahsetmek istiyorum. Profen Grup altında bütün bugün bir faaliyet gösteren teknoloji grubuyla 3 alt segmentte bu faaliyetlerini yürütmekte diyebiliriz. Bunlar iletişim teknolojileri, savunma teknolojileri ve uydu servisi olarak ayrılıyor. Yaklaşık 25 yıl, hatta 25 yıl aşkın süredir faaliyet gösterdiğimiz bu haberleşme teknoloji alanında sayısız projeye imza atmış bir entegratörüz aslında. Grup olarak da öyle, pardon. Profen İletişim Teknoloji olarak da öyle. Ve birçoğunuzun bildiği gibi de sektörün ihtiyaçlarına anahtar teslim, haberleşme çözümleri de sunmaktayız. Özellikle bu anlamda uydu ve kablosuz haberleşme sistemlerinin, bu sistemlere bağlı yer istasyonlarının ve ağların tasarımı, geliştirilmesi, sistem mühendisliği kabiliyetlerimizle birlikte kurulumu, entegrasyonu, temininin sağlanması, bunun içerisinde bütün entegre lojistik destek hizmetlerinin verilmesi, bu konularda uzmanlığımız ve tecrübemizle uçtan uca hizmet veriyoruz. Bu sistemlerin içerisinde ihtiyaç duyulan tüm ana ve alt bileşenleri ise gerek tedarikçilerimiz üzerinden gerekse kendi ürünlerimizle sağlıyoruz. Ar-Ge kabiliyetlerimiz sayesinde bugün uydu haberleşme teknoloji alanında başta olmak üzere kullanılan ürünlerin birçoğunu yerleştirdik ve yerleştirmeye devam ediyoruz. Basından da belki haber aldığınız projelerimiz var. İşte Milli Yer İstasyonu Geliştirme Projesi mesela çok yer aldı. Bunlardan bir tanesi. Onun haricinde taktik terminaller üretiyoruz, geliştiriyoruz. Bununla beraber alttaki bileşenlerden aktif pasif ürünler geliştiriyoruz. İşte amplifier'lar olsun, down converter'lar, up converter'lar, solid state amplifier'lar gibi aktif çok yüksek öneme sahip, bu sistemler içerisinde yüksek kritik öneme sahip ürünleri de geliştirip bugün üretiyoruz ve savunma sanayinin başta olmak üzere bütün kamu projelerimizde ve özel projelerimizde bu ürünlerimizi yerli imkanları sunuyoruz efendim. Savunma sanayindeki tüm vakıf kuruluşlarımız dolayısıyla bu kuruluşlarla, kamuya bağlı Ar-Ge enstitüleriyle, kamu ve özel operatörler ve servis sağlayıcılar çok yakın ilişkiler içerisindeyiz. Onların ihtiyaçlarına gerek entegratör rolümüze, gerekse bir yerinde Ar-Ge merkezi olmamızdan sebep araştırma ve geliştirme kabiliyetlerimize çözümler üretmeye ve hizmet vermeye devam ediyoruz. Bunlara ek olarak verebileceğim diğer örnekler yine çok daha kritik ihtiyaçlara çözümler üretiyoruz aslında. Sadece haberleşme alanında değil, haberleşme alanının bir tamamlayıcı ve yan segmenti olan yine stratejik ve taktik sistemlerle alakalı, işte bunlara izleme sistemleri de diyebiliriz. Keşif, gözetleme, algılama ve engelleme amaçlı sistemler. Ve yine bugünlerde ülkemizde de ve dünyada da çok trend bir konu olan siber güvenlik çözümleriyle ilgili de özellikle savunma sanayine çözümlerimizi sunuyoruz efendim. Uydu servisleri açısından bakarsak bugün hemen hemen dünyadaki bütün büyük uydu operatörleriyle işbirliklerimiz var. Uzun yıllara dayanan bir Türkiye başta olmak üzere bölgede çözüm ortaklıklarımız var. Bu uydu operatörlerinin bu bölgede faaliyet gösteren veya kapsayan uydularındaki kapasiteleri, geniş bant veri hizmetleri amaçlarıyla sunuyoruz. Bunları hem yer sistemleriyle birleştirerek hem de kapasite hizmetlerini de doğrudan sizlere paket halinde verebiliyoruz. Bu uydu haberleşmenin içerisinde yer alan geniş bant veri hizmetlerini aynı zamanda karasal altyapılarla da birleştirerek çözüm ortaklarımızla beraber uçtan uca sizlere aslında geniş bant ağ ihtiyaçlarına uygun çözümleri de getiriyoruz. Teleport hizmetlerimiz var. Yine birçoğunuzun bildiği üzere Profen'in Konya'da çok önemli bir yatırımı var. Ülke içinde örnek bir yatırım teşkil ediyor ve başlangıç yatırımı da diyebiliriz aslında bu alanda. Kamu firmaları haricinde özel sektör tarafından gerçekleştirilmiş en büyük yatırım diyebiliriz bu alanda. Hem bir uydu yer istasyonu olarak hem bir veri merkezi olarak faaliyet gösteren ve Tier 3 seviyesinde, hatta 3,5 diye geçiyor şu anki şeyde. Yani Tier 4'ün içerisindeki birçok gereksinimi de aslında sağlıyor durumdayız orada. Tier 3 seviyesi bir veri merkezi ve uydu yer istasyonu yerleşkemiz var Konya'da. Bu yerleşke üzerinden teleport hizmetleri veriyoruz. Hem geniş bant data hizmetleri, hem yayıncılık sektöründe içerik dağıtım ile alakalı hizmetleri buradan sunuyoruz. İstanbul üzerinden 2 tane yedekli, birbirine yedekli fiber çıkış bağlantımız var. Dolayısıyla yurt dışından gelen herhangi bir veriyi orada sonlandırıp uyduya çıkabiliyoruz. Uydudan aldığımız herhangi bir veriyi yine yurt dışına sonlandıracak bir operasyonu yürütebiliyoruz. Bugün söyleyeceklerim bu kadar. Çok teşekkür ediyorum katıldığınız için. Ben daha fazla sözü uzatmak istemiyorum. Ve Orolia firmasından bugün bizlerle birlikte olan David ve Eduard'a sözü bırakacağım. Etkinlik sırasında sorularınızı lütfen iletmekten çekinmeyin. Ekranın altında görünen QA alanına yazabilir ve bize iletebilirsiniz. Etkinlik devam ederken veya belki hani sunum yapacak olan arkadaşlarımın tercihine bağlı olarak sunumun sonunda sorularınızı toplu olarak cevap vereceğiz diye düşünüyorum. O yüzden sorum havada mı kaldı diye de düşünmeyin. mutlaka etkinlik sırasında sorularınızı siz bize iletin. Biz bunları takip ediyor olacağız. Ayrıca etkinlik sonunda bir anketimiz olacak. Bu da bizim pazarlama departmanı tarafında önem teşkil ediyor. Pazarlama verilerimiz anlamından. Geri bildirimlerinizi alıp bu etkinliklerin ne kadar verimli olduğunu, neleri iyileştirebileceğimizi onları değerlendirmiş oluyoruz. O yüzden değerli katkılarınızı esirgememenizi rica ediyorum. Hepinize tekrar hoş geldiniz diyorum. Verimli bir program olmasını ümit ediyorum ve sözü David'e aktarıyorum. Yes, David, thank you very much for your patience. Yeah, session is yours. Thank you.
Thank you, Necdet. Thank you for that introduction. Mahaba and hello, everyone. What we'd like to do today is present some information on resilient PNT, how to detect, protect, prevent disruption to your GPS and GNSS signals, and really focused on timing networks into critical infrastructure. So I think we've Necdet's actually talked about the agenda, so I'll just talk about the Orolia ecosystem and the problem and some of the solutions we've come up with. Then my colleague Edouard will actually give you an online demonstration of some of our solutions, and we will conclude with a question and answer session. So my name, as Necdet has said, I'm David Godwin. I'm the EMEA sales manager for Orolia, and Edouard is our applications engineer who will be doing the technical demonstration. I'll just give a few minutes discussion, presentation on the background for Orolia. So Orolia is a European company. We have a headquarters in France and also in the US. We have a large presence in the United States as well. We're a resilient positioning, navigation and timing company, globally based, many locations throughout the world. And Orolia itself is a combination of several different brands or companies from the PNT world. So you may have heard of these brand names you can see on the right hand side, but we're now all one company, which is Orolia. As I say, headquarters in France, in Paris and in Washington in the US, plus some other locations. Just really briefly talk about GNSS, just a quick refresher on what GNSS is. So a lot of people think about GPS, but actually the global system is the Global Navigation Satellite System, or GNSS. And there are 4 global constellations. GPS is one of them. There is also the European Galileo system, the Russian GLONASS system, and Beidou from China. There are also 2 regional systems, one in India and also one in Japan. And in terms of measuring GNSS performance, you need to have first the accuracy of receiver in terms of the time and the position of your receiver. Then we talk about integrity. So there is a level of threshold in confidence that the signal you're getting is the real signal. There are no anomalies, be that intentional or unintentional. The system needs to have a level of continuity, so you need to be able to trust it works without interruption. Then overall, you need the availability of a reliable GNSS signal, which basically incorporates accuracy, integrity, and continuity. And some of the systems we'll talk about will be using those metrics to decide whether your GNSS signal is trustworthy. So why do we need to trust GNSS? As we all know, GNSS over the last maybe 20 years has become a ubiquitous system. People use it all over the globe because it's very accurate, and it's free for the user to use, and it's available in most places. But the problem now is we have become very dependent on GPS or GNSS, and it's not just for location. A lot of it is about timing, and I think most of the applications we're talking about today for critical infrastructure are to do with using GNSS as a timing reference. and the system wasn't really designed initially for having this many users, and there are some inherent problems with GPS or GNSS. One is that it's a very weak signal, so it's very easy to have it to be interfered, both intentional and unintentional interference. And there are also, in terms of security, in terms of encryption, these things are not readily available. So there are, as our dependence on GNSS has grown, so has the vulnerability as well. And these types of threats come from various sources. They are unintentional threats, just unintentional RF interference from other sources, such as RF from transmission towers, cell phone towers, or even power lines. Anything that has an RF signature can interfere with your GNSS signals. You could have a geographical interference from landscape. If you're in mountainous areas, you may lose your sky view. If you're in an urban environment, you may get problems with reflection from multipath. And then there's intentional jamming. Intentional jamming may come from some privacy devices, which you can now buy, very cheaply on Amazon, which you can plug into your cigarette lighter in your car, and you can block the GPS signal for maybe 100 yards or meters around your vehicle. And that can have an effect on static infrastructure. But then there is also more sophisticated threats from state-sponsored activity, where there's either jamming or more problematic spoofing signals. And spoofing obviously is a bigger problem because you don't know you've been spoofed, and you just get an incorrect signal, which can then interfere with your whole system. And there have been some very well publicized cases of jamming and spoofing in the last few years, in the Black Sea, where ships were reported to actually be on dry land. In Finland, there's a continual episodes of jamming and spoofing in terms of up there in that area. At the Ben Gurion airport in Israel, there was GPS loss of signal for a week, and there's been several other cases where there have been issues with this GPS jamming and spoofing, right up to where last year President Trump signed an executive order where all critical infrastructure in the US has to address this PNT to avoid disruption. So in terms of adding or the subject of resilient PNT for critical infrastructure, there are kind of three segments. So we have your threat generalization and characterization. So taking your GNSS as your primary source of reference for time. So you have to look at that as an area of threat and how you can mitigate that threat through what we call IDM, or interference detection and mitigation. The sensor and signal fusion, we're taking alternative sources of reference, like there's a LEO satellite where you can actually get a very strong encrypted signals from LEO satellites. So that adds encryption. And then in the third area, you're talking about performance and certification of your network, looking at your cybersecurity, network timing to see whether how robust they are. And all those are centralized around central reference holdover oscillators and clocks and other PNT references, and fusing all these together into a common picture. So when we address threats to PNT services, we see this in three distinct layers. The first layer is detection. You need to be aware that there is a problem in the first place. And if you are aware of the problem, you can then make a decision to switch to an alternative PNT reference. That way, you've at least protected your system from actually getting compromised. The next level is protection. So actually, how do you combat or reduce the threat? So that can be by adding alternate PNT references, adding protection to actually filter out the jamming or the spoofing signals, and then actually working out how you can maintain that protection for the duration or for a certain length of time. And the final layer is actually data collection and analysis, to actually take the data you're collecting and get a common operating picture, get some intelligence from that in order to be able to then take mitigating action, or to be able to identify where that threat is coming from and maybe neutralize it. So Orolia, as I say, we have a layered approach to protecting your networks. So if you take the layers from the top, the first layer is actually the GPS or GNSS receivers. And actually the first step is to actually have receivers which are multi-constellation. By having a multi-constellation receiver, you add some redundancy to your signals, so that if there's a problem with GPS, you can switch to Galileo or to GLONASS. And if you have maybe 2 or 3 constellations, you can very easily tell whether one signal there is an anomaly, which quite often happens where GPS, the satellite, maybe has a problem, starts sending an erroneous signal, or you have a weak rollover event where the GPS satellites reset their timing as they count on weak numbers, and some older GPS receivers are unable to manage this very well. So there are various ways to protect at that level. We then add at the antenna level, we add passive and active antenna protection. So a passive antenna is one where you have a screen or a choke which will filter out signals from the horizon. And generally, most jamming signals come from the horizon, particularly if it's, say, a truck jammer, it will just be from the horizon. So a simple anti-jam antenna will be very effective at removing that signal. We then, for more sophisticated directional threats, we have active antenna systems, or what we call controlled reception pattern antennas. These have the ability to detect a jamming signal and steer a null reception pattern towards that signal, which effectively neutralizes the signal. So that's another layer, a more sophisticated approach to filtering out jamming. We then have the next layer, which is the signal interference detection software. So this is software which will actually analyze the incoming GPS signal and will detect if there are any anomalies or unusual patterns in the signals, which can normally indicate that there is maybe a jamming or even a spoofing event taking place. If that software detects this, it can then alert the user, and you can then have mitigating action, which is maybe switching to an alternative reference, flagging up the event, and then when it goes below a threshold again, you can switch back to your GPS signal. And then at that point, you can then switch to alternative navigation signals. So for a static facility that may be using a LEO satellite constellation of alternative satellite timing signals, it may be using pseudolights, or it may even be using, for a timing base, it could be even using a fiber optic network to have a network of master clocks on a fiber network. If it's on a moving, a vehicle, it could be taking navigation signals from an IMU or an inertial management unit, from a gyroscopic gyro, that sort of thing, a fiber optic gyro. And then using sensor fusion software to combine those signals. And then finally, we have our internal references, which are different oscillator types. And we even have, up to rubidium, very small scale atomic clocks, which are able to maintain very accurate time over several days, depending on how much accuracy you require. So in terms of the GNSS security framework, this is now more common practice of this layered approach, or these levels of security. So we have levels 1 through 4. So level 1 is just ensure recovery after threat removal, but adds no additional timing holdover. Level 2 adds some unbounded holdovers to ensure you can maintain your operation, but your error will increase over time. Level 3, you can actually constrain the error by adding certain alternative reference signals of alternative reference, which makes your error is reduced, so you can maintain a bounded error. And level 4 is actually where you have no error at all, where you're actually maintaining operations with absolutely no degradation in your signals. And that's obviously the level which ultimately is the optimum level to reach. And these security frameworks have been driven very much in the US by the executive order. And there's some in Europe, we have several initiatives by the European Union, including the Cybersecurity Act, building a GNSS security framework. So in terms of how we map our solutions to this security framework, or this GNSS framework, so we have 2 columns. We have jamming threats and spoofing threats. So you can see from this diagram, we can have on level 2, for instance, we add our oscillators, our rubidium atomic clocks, which are able to maintain very accurate time over extended periods of holdover. We can add our different antenna options to remove some jamming threats, so that's already reducing the threat. We have our software, our IDM suite, which then adds spoofing detection and awareness. You can then add, to get to level 3, we add local alternative time sources. This could be your IMUs, other oscillators. And finally, up on level 4, you actually have adding maybe a network of primary reference clocks accessed over maybe an optical fiber network, maybe using White Rabbit, very high accuracy synchronization. It could be using alternative time references such as SDL, which is a LEO-based satellite network, offering very accurate timing over with encrypted signals, which make it very hard to jam or spoof. ELORAN is another option which is used is available in certain areas as well. So as you can see, you can build up the levels of protection, resiliency, and all these systems can be added to our reference clocks. So I'd like to now switch to some of our PNT applications, just to give you an idea of where these applications or where our expertise comes from. So in terms of frequency sources, so our atomic clocks that we build in Switzerland are used in everything from hydrogen masers on the Galileo network of all the Galileo satellites are using our hydrogen masers. We have rubidium clocks, which are used as references also on the Galileo satellites, but also in other timing references in aircraft in our own timing products such as VersaSync and SecureSync and other SATCOM applications. In terms of sort of intelligent transport networks for kind of the transport of the future, we're using systems built into kind of smart cities in terms of V2X or vehicle to infrastructure applications. This is where, taking our simulation capabilities to test infrastructure, SecureSync to actually distribute time within these types of networks. And then really more in terms of, more static locations, distributing timing typically being NTP or PTP into maybe financial or industrial applications. And again, you're taking your GNSS satellite signal, adding our resiliency layers, creating, having a SecureSync master clock distributing time over a network with STL as a backup. Process control, very common application, again, where you're needing to timestamp data. Maybe you're on a production line feeding out products which need to be timestamped. So you need a reliable timestamp and a master clock to actually provide that timestamping, which can then be, there is a proof of that timestamp. So again, very typical to use our technology to provide that. And finally, for public safety, for instance, in the US, all the public safety network uses secure syncs to actually have accurate time, so you actually know when an emergency call is made, it's timestamped, so everything is recorded and is verifiable. I'll now just briefly introduce the actual platforms themselves, the typical platforms which we deliver to actually provide these solutions. So we have two main kind of form factors for different types of environments. So secure sync is our classic rack-mounted 19-inch 1U unit, which is really our bread and butter product. We've sold tens of thousands of these systems. This is really our master clock, which is then provided for taking a GNSS reference and then providing all sorts of whole range of different signals into your infrastructure. Then we have the Versa platform, the Versa Sync, and the Versa Pnt, and the Versa Sync really takes all the applications from Secure Sync and puts them into a very small, ruggedized, small form factor, small size, weight, and power unit, which can be built into either a very rugged, harsh environment or into a small environment, such as a vehicle or a UAV or an aircraft, where you have very limited space, but you require all the same timing functionality. And the Versa Pnt then adds your navigation and positioning. So adding IMU and sensor fusion to then basically take different signals of reference to actually add that ability to add, accurate positioning and navigation to the timing. So in terms of just looking at the secure sync, so this is our reference time and frequency source. In fact, this is our new system just pictured here. A very easy user interface, all controlled from the front control panel or through a web GUI, so you can control it remotely. So this will have a multi-constellation receiver. So take Galileo, GPS, GLONASS, Beidou. Also has SASM and M-code options, and will have PRS, which is the European version of M-code, when that is available. So you can even have that secure encrypted signals as well. And it comes with option cards, allowing you to have a very wide variety of signal outputs. It has built-in NTP and PTP options, 10 megahertz and 1 PPS, all built in as standard. And it is exceptionally robust, very wide temperature and humidity control ability to work within those environments, and best-in-class security and networking. Versa Sync has all that same capability in a very small form factor. So instead of having option cards on the back of the system, this system has a configurable input and output port, which enables you to then configure the system through the web GUI to actually input and output all the signals that you require for your system. And this is built to US MIL standard 810G, so it's very rugged, can withstand high vibration, shock and load. So we look a little bit more at the Secure Sync. As I say, particularly with this newer version of Secure Sync, it's really focused on networking, security, redundancy, a wide range of option cards, and as I say, built-in PTP and NCP for maximum convenience. So as a typical configuration for data centers and financial services, so you take your GNSS reference, and then you need to output different, multiple outputs. You're typically, for financials, you're having PTP, NTP is still widely used as well. And then you're adding maybe 1 PPS as well. And then you need to have the resiliency as the differentiator. So then you're adding STL, anti-jam antennas, simple active antennas, and the IDM suite. So financial services, just a quick note on that. So particularly in the UK, we did a lot on financial services where they're doing time stamping, high frequency trading, where you need to be You need to have an audit trail where you need to be able to verify that your timestamps have been made when they've been made, and you can record all that. And these systems are perfectly designed for that. Or if it's in data centers, again, timestamping is very critical to ensure that packets are timestamped and arrive at the right time. Just a few other use cases I won't go into in detail, but there's for plant automation or pharmaceuticals, that's we have very nice use cases which we can share with you after the meeting. Power authorities for smart grids, financial centers, as I say, for high accuracy timing and GNSS timestamping backups. And here's just a few examples of commercial customers that are using our system. So Roder and Schwarz use it heavily on data, communication systems, Schneider Electric on process control, Google, we have Facebook, Microsoft for data center management. Again, just getting an idea of some applications where we've supported them with our resilient Pnt solutions. Just a few options that we can do, as I say, the protect, detect, recover. So in terms of secure sync, so the options are, we talk about multi-GNSS, which is built in. STL, I'll just talk a little bit about STL, is a service from Satellis, who we partner with, in a US company. They use the Iridium network of low Earth orbit satellites, which are not used for satellite phones. We use them also for effectively an alternative GNSS type signal. So the advantage of the STL signal, it's 1,000 times stronger than GPS. So it's very hard to jam, and it's encrypted, so it's very hard to spoof. So this is an option which is built into all our systems and gives you a very, very accurate, reliable backup to GNSS. We also have our GPS IDM suite detection software, which will then analyze your GPS signal to detect if you're getting jammed or spoofed. And then we have our antennas. The 8230 anti-jam antenna is our passive antenna, which filters out signals from the horizon. The GPS dome is an active antenna add-on, which basically enables you to detect a jamming signal and then block out that signal, and therefore allow the good signals to come through. So it's a very nice complementary system. And these are all add-on options to Secure Sync and also to VersaSync. Yes, here's just a slide on Satellis. So as I said, it's 30 dB or 1,000 times stronger than GNSS. So it makes it almost impossible to jam. It can be used indoors because of the strength of the system. So a lot of our customers, for instance, in financial or any customers who are operating in a building, you can actually get the signal will penetrate into the building. So you just have a local antenna, which means you don't need to put, sometimes it's difficult to put antennas on buildings. And so the STL will actually has a very small antenna, which doesn't need to be on the roof of the building. This is just a slide, a bit more information on our IDM suite. As I mentioned, it detects the signal, the GPS signal, and here you're listed the actual wave forms which are being analyzed and the kind of spoofing activity which is being detected. And we're updating this all the time. We work very closely with the US DoD, with our secure facility in the US. So this is generally up to date and a very effective way of giving you protection against jamming and spoofing. Briefly, we've added very recently 7 solutions, White Rabbit. So White Rabbit is a high accuracy timing signal originally developed at CERN, the CERN labs in Switzerland. And this gives literally sub-nanosecond PTP over fiber, over large networks. It can be over hundreds of kilometers, multiple nodes, and you can maintain really nanosecond or even sub-nanosecond timing accuracy. And we can actually add this architecture. We actually supply this timing infrastructure, and this works very well with our Secure Sync. So as a typical installation, you take Secure Sync as your timing reference, your master clock, feed it through to your White Rabbit broadcast, which then broadcasts it through or transmits it through your fiber network to your different nodes, and then can be, as I say, distributed over hundreds of kilometers without any loss in accuracy. So a very, for very highly networked or highly accurate systems, if it's radio over RF, some alternative timing or PNT signals, this is a very good solution. Okay, I think I've talked enough about and hopefully given you an idea of some of the solutions and basically technology we have. I'd now like to hand over to Edouard, who will then give you all a demonstration of some of our solutions. So Edouard, over to you.
Thank you, David. Can you switch to the next? Oh, okay. I will share the. Can you see my screen?
It's just coming up. Yes, I can see that now.
Okay. So just before we get started into the online demonstration, I would like to go over the equipment setup that we have here and run through the web user interface of the Secure Sync. Can you see the demo setup? My diagram, can you see that?
Yes, we can see it now.
Okay. So first, I have a Secure Sync that is running the interference detection and mitigation feature David presented earlier, which is embedded into the Secure Sync software and is a licensed software option. And then we have a combiner which has one port connected to the LiveSky GNSS antenna on the lifestyle, and the other port is connected to a GSG, which is a GNSS signal generator, which is also known as a GPS simulator. So in this case, we will use it as a jamming sources. What we will do during the demo after the web user interface overview is adding a jamming signal in mixed with the LiveSky signal to mimic jamming. We will turn on the jamming of the sources, and we will mix that with the LiveSky signal to feed into the Secure Sync, and then observe what happened. So of course, this test can be done over the air in an anechoic chamber, for example, but performing that kind of test outdoor is dangerous, as there are very strict regulation regarding radiating signal outdoor. So you have to be aware of that if you are not already aware. So now I head to the Secure Sync. So I will remove this diagram. So this is the web user interface when you log onto the unit through the network. So I will log onto it. Okay, now we are logged. So this is the home screen of the Secure Sync web user interface, which provides comprehensive status information at a glance, including vital system information on the left side here, current status of the different references available for synchronization, also key performances or accuracy data here, and also major log events. We can see here on the home page the different reference available. So for example, in our case, we have GNSS reference, PTP reference, ASCII timecode reference, and also NTP reference. So currently the GNSS reference is valid and selected, but we can see other references that are listed in order of priority, meaning that if something goes wrong with the GNSS reference, the system will choose the next valid reference in the list. In case we don't have any other valid reference, Secure Sync will not immediately declare loss of time synchronization, but first will go into holdover mode. That is when the unit will run on its own internal clock relying on the internal oscillator performances to try to keep the time as accurate as possible. So thanks to the stability of the internal oscillator, accurate time can still be delivered even after all the primary references are no longer valid or present. The more stable the oscillator is without an external references, the longer the holdover period can be and have it still maintain very accurate outputs. The benefit of the holdover is that time synchronization and the availability of the time outputs is not immediately lost when input references are no longer available. So while Secure Sync is in holdover, for example, there are no changes to the NTP or PTP provided over your networks. So while in handover mode, the NTP inside the Secure Sync continues to be at the same stratum level as it was before going to holdover merge. So for example, in this case, we are in stratum 1. If we have a loss of GNSS signal, the unit will go into holdover, but will remain in stratum 1 and provide NTP over the network. If the holdover period expires or the unit is rebooted, the NTP stratum will go to 16, preventing any clients from being able to sync with Secure Sync until GPS or another reference has been restored. On the web user interface, we can also see the primary navigation bar, which provide access to all the different menus. So the home is to return to the home screen, of course. The interface menu allows the access to the configuration pages for the references, for the outputs, and for all the different option cards installed within the equipment. The management window allows the access to all the network setup screens and other setup screens such as the reference priority table, the system time, and also the oscillator settings. The tool section, it opens a drop-down menu for access to the system maintenance screens and all the system logs. And of course, the monitoring state window, which display the IDM suites. So I will display later on. So if we go back on the interface menu, for example, we can see that it provides access to the Secure Sync, so the external references. So for example, we can have information regarding the current GNSS input, thanks to the GNSS link to the antenna. And we can have information on the current satellite signal strength, and also the other information such as the constellation selected and that kind of information. We can have also some graph regarding the current satellite reception, depending on the different time scale. And we can have such information for all the different input references. We can also have information regarding the different outputs available in our unit, and more generally on all the option cards. So if I go on the option card section, for example, we can have an overview of all the status screens for the respective input and outputs of the option board. So here we can see the rear panel of our current unit with all the different option boards detected and the status of those option boards. Clicking on any of the line item will open a status screen. So, and providing real time information on the selected interface, availability, performance data, and also event history. To configure settings for the selected interface, we can click on the gear icon or button provided on most of the status screen. So if I, for example, open the PTP option board, you can see that we have quickly access to all the different settings of this option board, and also all the different status of the option board. So for now, it's listening on the network if there is a PTP master to sync on. If I switch to the management menu on the web UI, we can see that it provides access to secure sync configuration screens and settings. So on the left side, we have all the network settings. So following some standard setup screens, we can find the network setup, for example. I won't go through all the menu, but this one might be of interest. So in my current unit, I have a network option board allowing different Ethernet ports, so we can quickly have access to each status of the ports and the settings of each port. But we can also have access to the general settings of the network, also the HTTPS setup, the SSH setup, and many other network setups. So as you can see on the left side, we can enable or disable many network services, allowing a different level of security allowed by our units. On the management menu, we can also see the other section. So we can access to non-network related screen. For example, the authentication. The authentication menu allows to manage the user accounts, the security policy. So for example, the LDAP setup for some security reason, but also the radius setup or the TACAC setup. We can also modify the logging preference and set a remote server. We can also modify the password if required. Also, I mentioned the reference priority. We can define the order of priority for the timing inputs, and we can also set the number of inputs. So we can have up to 15 different timing inputs. So this is where we will select the different inputs. Of course, there is all the notification menu. So it defines configures the notification triggered by secure sync events. So the notification can be a combination of a mask alarm and or SNMP trap and or an email, for example. Then we have the time management to manage the local clock, the UTC offset, the DST definition and leap second information. We can have some setting regarding the front panel of the unit. So we can configure what is the appearance of the secure sync front panel display and also the keypad. So on the front panel of the unit, you have a keypad. You can decide to lock the keypad if necessary to avoid any trouble on the maintenance side. And then we can have access to the log configuration to manage all the system logs. And after that, we have also the disciplining regarding all the oscillator settings and the management of the oscillator, and all the administration for regarding the password settings. After that, I can quickly switch to the tool menu. So the tool menu provide access to the system upgrade screen. I will show you that. And also it provides access to different system and network monitoring screens, which can be useful for remote monitoring and some troubleshooting of the units. Under the upgrade and backup screen, we can see that we can update remotely the units or apply a license file remotely as well. This is where we will get all the information regarding the current system we are using, so such as the model, the software version running on the units, which oscillator is installed in the unit, what is the GNSS receiver installed, and what is the software of the receiver, and then all the information related to the different option board installed in the 6 different option board slots available. Then last but not least, the monitoring menu. So I will go on this menu. The IDM switch is the features David talked about earlier. So looking at the IDM page within the Secure Sync, we can see the IDM broadsheet dashboard. So the IDM means interference detection and mitigation features. So as a reminder, the IDM suite is an optional software module for Secure Sync that is capable of detecting the presence of GPS jamming and or spoofing in real time. So there are two types of IGM suites accessible. There are two types of IGM suites access available on the unit. If you meet the right security qualification, SecureSync provides the jamming only portion through a software out patch, and the full jamming and spoofing functionality requires a purchase license. So the IGM features just does the detection, and it notifies the SecureSync of that detection, and then the SecureSync invalidates the compromised GNSS reference. So the IGM suite monitor the GPS signal frequency band by applying proprietary error detection algorithm. So we use over 75 algorithms checking different parts of the signal, different characteristic of the GPS signal in order to detect whether jamming or spoofing is present. So if a threshold signals monitor, if a threshold signal monitoring value level is exceeded, the SecureSync will emit a major alarm, and depending on your system configuration, invalidates the GPS reference, causing SecureSync to either transition into holdover mode or go out of sync. Even if you decide to turn off the SecureSync's auto sync control on the left side features, which allows the IGM suite to disable the GNSS reference, the features will still add value to your overall system capability by telling you if your GNSS receiver is being spoofed or jammed, and in the event of a signal loss due to jamming, why the signal is lost. Also, if a normally strong GNSS signal becomes weakened, the algorithms are capable of discerning a jamming event from natural events, causing the signal to weaken. So this is the default view of the feature, and we can see on the left we have some status and setting option, and the dashboard takes up the rest of the window. So first we will cover the dashboard. This is where the most of the important operational data is displayed. Starting with the graph on the top left, we see the system state. So this graph represents the cumulative penalty scores for jamming and spoofing. The black line here in the middle is the critical line. So when jamming or spoofing scores breached this line, the IGM software considered the environment jammed or spoof. In the banner at the top of the dashboard, it will turn in yellow for jamming or red for spoofing. So we can differentiate between jamming and spoofing by looking at the color of the line on this graph as well. So right now we can see that we don't have any spoofing or jamming, but there are some events that can occur during the day that will trigger some of the algorithm, and you might see little spikes, but as long as this is within the number range, everything is still fine. That's why we really use a scoring system where it has to be multiple things that are feeding the algorithm on one thing that weighs very highly, so that the line goes above the critical line. That are feeding, and that's when jamming or spoofing will be detected. Moving to the top right window, we see the number of SV, meaning the satellite vehicles use graph. So this graph plots the number of satellite vehicle the receiver is the GNSS receiver is using. So below this is so this graph here, this is the carrier to noise ratio graph. It depicts the average signal strength from the tracked satellite vehicles for the internal receiver. And at the bottom is the GNSS spectrum. So this is a 16 megahertz wide representative spectrum centered around the GPS L1 frequency. So this is not a raw RF spectrum. This spectrum is just representative based on the output of the receiver, and it is not a spectrum analyzer. So you can see some spikes, but it is just the way the data are interpreted. you can just you can't measure the power with the spectrum, but you can see the type of waveform present if it is strong enough. So all the graph here can be viewed in a variety of time window by clicking on the tabs under the dashboard banner. So for example, here is the history for the last 1 hour, the 3 last hours, and the 6 last hour, and so on, for example. So as you can see, during the last 3 hours, there was some jamming and some spoofing. This is when I performed some tests, and I will show you right now a jamming example. So first thing we will do is adding a jamming signal. So I will just move to the last hour history. I will add a jamming signal. So I have a jamming signal setup that I am going to add to the secure sync. The jamming signal is a swept frequency signal, and it mimics a chirp jammer. So let me enable this signal. Okay. So it is going to mimic a chirp jammer. So we can see in this case on the GNSS spectrum, we will see a different waveform. Here it's changing. So it's a pretty strong jamming signal, and we can see on the top left graph that the signal goes way above the threshold. So our score went way up, and it detected jamming very quickly. So it turned orange on the banner. Now, if we go back on our reference page, we will see that the status of the GNSS now is invalid. You can see the red lights. So for the GNSS reference, the status for the GNSS reference was invalid. So the units decided to switch to another reference. But in our case, there were no other reference available. So this is what I explained earlier. The unit is now into holdover mode. We can see on the left side the status. The holdover mode, the hold LED is on, meaning that the system is currently relying only on the internal oscillator performances to provide accurate time to the network. As you can see also, we are still in stratum 1 for the NTP, meaning that the system is still providing stratum 1 accuracy to all the networks on which it is integrated. If I go back on the IGM page, so we will see that as we saw, there are some jamming effect. I will now disable this jamming signal, and you will see that we wait for a few minutes for a cycle of good live GPS, and we will see that the indication will fall down below the critical line. It's already decreasing, so below the critical level. We can see already that the spectrum below that the jamming has gone away, and now we can see that the IGM feature has detected that everything is okay again. So now it's turned green, meaning that the GNSS signals is no longer compromised and is considered as valid enough. So if we go back once again on the home page and to see the status of the different reference, we can see that the GNSS reference is now considered as valid again. It is selected by the time server to discipline the internal oscillator, and we can see just below in the performance window that the current state of the disciplining state of the oscillator is tracking setup, meaning that the oscillator is using this good reference, so the GNSS reference, to discipline the oscillator and then to provide accurate time over the network. So if we are waiting a few more seconds or minutes, we will see that the unit is once again synced on the GNSS reference, and that thanks to the IDM software, we avoid a jamming event. Now, if we go back on the IDM software, you can see that the jamming level is disappeared, in fact, and everything is back to normal. So now we just have to wait for the internal simulator to get disciplined thanks to the GNSS inputs. But thanks to these features and the auto sync control option enabled, we were able to protect our timing system against an intentional, in this case, jamming effect. So I am only showing you an example of jamming, but it will be similar to spoofing. The spoofing will be detected, and if it is above the critical line, the unit will go into holdover or will switch into another reference available if there is any. So yeah, we can wait a little bit more. We can see that in the system status that the reference which is used to synchronize all the operation is the GNSS reference. We have a quite good accuracy between 10 nanosecond and 100 nanosecond, and which allows us to provide a very accurate time through all the timing option time code protocol available thanks to our units. So for example, PTP or NTP, but also E1 or T1 or 1 PPS 10 megahertz, and all the other timing and frequency signals we can provide. That's all for my demo, David. If you want to share back the screen.
Okay. Sure, thank you, Edward. That was great. A really nice kind of graphic, visual way of seeing the capabilities of Secure Sync and the ability to manage the input signals and the output signals, and really see get an operational picture of the status of your signals, the quality of the signals, and also which references are using and which references you have as options, really. So that was a great sort of taster for that. I think, Edouard, if you just let go of the screen. I mean, I've just got really, I think we're coming towards the end of the presentation. It's really more of just questions and answers, really. So I think there's a couple of questions up on the chat screen which I can start with, unless there are any live questions. But maybe we'll start with I've got a question here about, do we support power grid PTP profiles? And the answer is that's an interesting question. That as an application for resilient timing, power distribution, so basically distributing power through the electrical grid, so transmitting your mains electricity over power grids, there's a big move now to make what we call smart grids, where so with smart grids, in order to be more energy efficient, you need to be able to very accurately know the time and phase of your AC alternating current electricity. And there's a range of power profiles, and there's actually a power profile 61850, which is a range of power profiles specifically for the smart grid applications. And we will be supporting these profiles this year with a range of timing solutions targeted at smart grid. So yes, so the answer is we will be supporting that. And it's a very interesting application area, because one we see growing, it's been driven by our customers in Switzerland, where they've developed this very extensively with ABB and Swiss Grid and a few others. We're seeing it more and more. So yes, we'll be supporting that. There's another question about timing standards for broadcast, and and these have been around now for a while. And again, it's PTP. So really, for network timing, it's PTP is the profile or the application that is most supported. So there's the SMPTE 2059 and AES 67 are two specific broadcast profiles used really when you're doing broadcast over IP, and that's something we will be supported again this year with a range of PTP products. So yes, broadcast is something that is a real booming industry and one, or booming applications, taking from single net, for single frequency broadcast, which is the traditional form of broadcast, to broadcast over IP, which we're all doing now with streaming and Netflix and that sort of thing. Are there any other questions?
Thank you, David. Thanks for the answers. Evet, başka soru iletmek isteyen var mı? Programımız sonuna geldi. Sunumlarımız bu kadardı. Umarım fayda sağlamışızdır. Herhangi bir sorunuz, aklınıza takılan bir şey ya da işte anlamadığımız bir yer, tekrar şurayı anlatır mısınız diyebileceğiniz bir yer varsa oralara da geri dönüp üzerinden geçebiliriz. Yani açık bir nokta kalmasın ilgi duyduğunuz bir tarafla ilgili. Evet. Teşekkür ediyoruz tüm katılımcılarımıza. Bu saate kadar bizi dinlediğiniz için. David ve Edward bizdeydi Orolia'dan. GPS, GNSS sinyallerinin bozulması ile alakalı bizlere Orolia'nın çözümleri ve teknolojik gelişmelerin burada nasıl imkanlar sağladığını gösteren bir anlatımda bulundular. Thank you, David, for the presentation. It was very beneficial, and Edward, thanks for this demonstration session also. It is really useful to be more familiar with the Orolia solutions based on interfaces, especially. I think we are all done. There is no other question. So have a nice day. I hope you have a nice day, and see you for the next event. Teşekkür ediyoruz tekrar katılımcılarımıza. Herkese iyi günler diliyoruz. Ayağınıza sağlık. Bu konuyla ilgili bizimle e-mail yoluyla da iletişime geçmek isterseniz cs@profen.com'a mail atabilirsiniz. ceyhansamsun@profen.com'a mail attığınızda konuyla ilgili arkadaşlarımız, ben sizlerle ilgileneceğiz. İyi günler diliyoruz efendim. Hoşça kalın. See you, David. See you, Edward.
Thank you.
Thank you very much.
Bye bye.
Bye.